Hey there, course 1, lesson 49, we're going to divide not only with decimals, but divide by a decimal. So we're going to have a divisor that's a decimal along with our dividend decimal. They're both decimals, and there's two ways you can look at these problems. We'll talk about the over-up method at the end of the lesson. For now, we're going to look at 24 hundredths divided by 4 tenths and think about how can we make it so the decimals just disappear so we don't have to think of them as parts. We'll get the right answer, but we can make both numbers look different. I wonder how I could do that. Think about it. Recall if I multiply both numbers in a fraction by the same amount, I get the same answer. For example, 1/4. If I multiply both the top and the bottom by 2, I'm really not changing how much pie I have, I'm just changing how many cuts. 2/8 is still equal to 1/4. I just renamed it, if you want to call it that, by multiplying by the same number. Now with decimals, if we always multiply both the top and the bottom by 10, we get an easier number, 10 on both the top and the bottom. Because remember, a division problem is really just a fraction. This line here really just means divided by. So this is showing the same thing as this. And remember, we can change fractions the way they look without changing what the answer is, the quotient. 24 hundredths times 10 is, I believe, 2 4 tenths. 4 tenths times 10 is 4. I like that a little better, but I think we can still make it better. Let's multiply this by another 10. Now I get 24 over 40. And then I could reduce that down, dividing by a common, maybe 2. So I get 12 over 20. 6 over 10. 3 over 5. I guess I could have divided by 8 on that. So it ends up as 3/5, which I like that as an answer. So what does that look like over here? I multiply both of them by 100, making this 40 and this 24. No more decimals, except I'm going to need one right here. Right? And now I put 40 into 240, remembering that there's a decimal here, and I'll end up getting a decimal that way. So you can either do it this way or you can do the fraction way. Now let's see what the book has to say about these. It reminds us that when the divisor, so in this case 4 tenths, is a decimal in a dividing problem, we want to change that divisor to be a whole number. So in this problem, they multiply 4 tenths by 10 to make it 4. Not 4 tenths, but just 4 here. But if you want to multiply the divisor by 10, you also multiply the inside number by 10. I guess they changed problems down here. Let's go back up to this one. Multiply it by 10 becomes 4 for the divisor, and then the dividend we have to also multiply by 10. Now they don't change this one. They leave it as 12.4. They just say get the divisor to be a whole number. Okay, and we did that by multiplying by 10 because it was in the tenths place. That gets it to be 4. Then 4 goes into 12 3 times. And they give us a nice one because we drop down the 4 and 4 goes into that once. So it's 3 1/10, or you can write it as 3 1/10. Either one would be correct. Maybe show it as a decimal when you're working with decimals. How are we doing so far? So to do division problems where you're dividing by a decimal, we change the divisor to a whole number by multiplying by a power of 10. Okay? So they did the problem that we just did here on page 255. They do a similar one, but this time, how is it different in example 1? Divisor, or the denominator, the way it's shown here, is now in the hundredths place. So what will we need to multiply by? 100 on the top and on the bottom. Making this 4 and making this 124, they perform the division, comes out evenly to 31. Take a closer look at that if you need to. Now, here's the over, over, up that I promised. When you're multiplying by 10 or 100 or even 1,000, really what you're doing, let's say if I have 0.3 and I multiply by 10, all I'm really doing is moving the decimal however many zeros there are in that factor. There's 1 0 here, so I move the decimal 1 time to the right because I'm getting bigger. So the answer is 3. It's kind of your shortcut. If I had hundredths, I would multiply by 100 because there's 2 zeros, moving this twice and giving me a whole number divisor. If I had this, but for some reason I multiplied by 1,000, I move it 3 spots, right? And I need my placeholder 0 now. So gives you an idea what the shortcut really looks like. When you're multiplying by tens, you just move the decimal over as many zeros there are. So we can think of what we do to make divisors whole numbers maybe easier by just moving the decimal over to the right the same number of times for both the divisor and the dividend. They only need it over once for the 6, so we only move it once in the 14 4/10, making it, sorry, we got to move it from where it was to here. So that makes it 144. And we moved it over once to get a whole number 6. Then we put it into the division, right? Giving me 24, I think. Even. No remainder, no fraction. 24 is my answer. And I did it without having to deal with any decimals in the long division because I multiplied what? Both divisor and dividend by what? 10. Very important, both get multiplied by 10. The same number has to happen. Let's talk about letter A. We would multiply divisor and dividend by what number to make the divisor, which is the bottom number, a whole number? Well, it's 1.2. How many spots do we need to move it to make it a whole? Just one. What number has 1 0? This one, right? We're going to multiply top and bottom by 10 to perform that division. So the answer is 10. Good? How about this one? It looks different, but similar principle. 144 thousandths divided by 12 hundredths. Multiply this by how many zeros to make it a whole number? 2 zeros. What number has 2 zeros? How did I figure that? Because there were 2 numbers after the decimal that I needed to move it. 1, 2, and there's 2 zeros in 100. We would multiply it by 100 to make it 12, which is a whole number divisor. See? Just what you want. All right, we're wrapping up lesson 49. Use the process that we've learned and pick 3 of these and then do K. 3 from here and then K. So you're doing 4 total problems, please. Good luck.